Series, Video 2. In the last video, we considered this nice little picture. Divide the remaining area in half and shade one of the halves, and then start adding them together. Clearly, when we add all those areas together, we would get a finite value. Let's consider some other examples. But first, let's make a definition of convergence and divergence of a series. When we say series, we want to think of it as an infinite series. So what does it mean for the infinite series to converge or diverge? Well, like we saw in that example of a rectangle, we consider partial sums. Instead of taking all infinite many, we approach infinity in a limit. So we want to watch what happens as capital N goes out to infinity. Is this sequence a convergent sequence? If it is, then the series converges. If the partial sums do not converge, then the series will diverge. Good. Some examples. Let's take the infinite series where we're adding n over n plus 1. Note that n over n plus 1 will limit to 1. And you know that 1 plus 1 plus 1 plus, keep on adding 1 together, you're going to get an infinite value. Okay, but to consider this series, let's consider the partial sums. If n is equal to 1, the first term will be 1 over 2. To get the second partial sum, we use the first partial sum and add in the next term. N is equal to 2, so we get 2 over 2 plus 1. Let's use the fact that 2/3 is bigger than a half to see that S sub 2 is bigger than 2 copies of 1/2. Good. S sub 3 is going to be all of S sub 2, but now with n equaling 3, we want to add in to S2 n over n plus 1. Since S2 was bigger than 2 copies of a half and 3/4 is bigger than a half, S3 is bigger than 2 copies of a half plus 1 more copy of a half, in other words, 3 copies of a half. Same thing's going to happen on S4. If we look at S4, it is S3 plus n over n plus 1. And this n over n plus 1 is again bigger than a half. So 3 copies of a half plus 1 more copy of a half is bigger than 4 copies of 1/2. Very nice. So in general, we can see that S sub 4 was bigger than 4 copies of a half, or S sub n is bigger than n copies of a half. And n over 2 will go out to infinity if n is going out to infinity. What was this all for the purpose of? To show that this series diverges as the sequence of partial sums diverges. Nice. Try an even easier one. Let's say we have an infinite series where our sequence is -1 to the n. When n is equal to 1, we'll get -1. n equal 2, we take the first term, add in the next term, comes to 0. S3, we take S2, which is 0, and add in the next term, -1. So we're going from -1 to 0 to -1, back to 0. That's going to be the pattern. Therefore, this series also diverges. One more example. let's look at the infinite series where we're adding 1 over n times n plus 1. Okay. If n is equal to 1, then 1 over 1 times 1 plus 1 is 1 over 1 times 2, or a half. Now, s sub 2 will be that same first term plus, now the n equal 2 term will be 1 over 2 times 3. 2 times 3 is 6. First term is a half. Writing that out, combining these terms, we would get 3 plus 1 is 4. 4 over 6 is 2/3. For S3, let's add into S2, which is 2/3. The next term, the n equal 3 term, 1 over n times n plus 1. Creating a common denominator, get this quantity, 9 over 12 will simplify as 3 over 4. So now 3 over 4 is s sub 3. To S3, we want to add the n equal 4 term, 1 over n times n plus 1. Same idea, simplify out, and you get 4 over 5. Notice the pattern. For n equal 1, it's 1 over 2, n equal 2, 2 over 3, and so forth. So the capital Nth partial sum will be capital N over n plus 1. Taking the limit as capital N goes to infinity, we're going to get 1, which tells us that the series has a value of 1. 1 is a finite number. Therefore, this series converges. Excellent.